What happens inside a black hole? The moment you can't escape. The last moment of normality. Imagine this. You're floating in space. No sound, no wind, no up, no down, just silence. And in front of you, something is wrong. At first, it doesn't look like anything, just a patch of darkness. But then, you notice it. The stars behind it are bending. Light itself is curving, like the universe is being pulled toward a single point. You don't feel fear yet, not really, because your brain doesn't recognize it as danger. There's no explosion, no fire, no warning, just distortion. But then your instruments start to fail. Your navigation system flickers. Your sensors spike. Gravity readings are rising, fast, too fast. And suddenly, you realize something terrifying. You are not just looking at it, you are already falling. The invisible edge. Black holes are not objects in the way we imagine. They don't have a surface. They don't have a solid boundary. There's no wall to hit, no line painted in space that says, "Stop here." And yet, there is a boundary, a point of no return. Scientists call it
the event horizon. But here's what makes it truly unsettling. You can't see it, you can't feel it, and when you cross it, nothing happens. No flash, no impact, no sign that you've just crossed the most important line in the universe. Because the event horizon is not a place, it's a condition, a limit, the exact point where escape becomes impossible. Why nothing can escape? To understand this, you have to think about speed. Everything in the universe has a speed limit. Nothing can go faster than light. Not rockets, not particles, not even information. Light is the ultimate speed. Now imagine this. What if gravity becomes so strong that even light can't move fast enough to escape? That's what a black hole does. It bends space itself inward so deeply that all paths lead back in. Not because something is pulling you back, but because there is no out anymore. Space itself is falling inward, and once you cross the event horizon, every possible direction leads deeper into the black hole. What others see. Now here's where things get even stranger. From your perspective, you're falling normally. Nothing feels unusual. But to someone watching you from far away, something impossible is happening. They see you slow down, more and more, as you approach the event horizon.
Your movements stretch, your signals weaken. Your voice, if they could hear it, would drop lower and lower until it fades into silence. And then you freeze, right at the edge, never crossing, never disappearing, just stuck, forever. Time is breaking. This isn't an illusion. It's not a trick of light. It's real. Time itself is slowing down. Near a black hole, gravity doesn't just affect objects, it affects time. The stronger the gravity, the slower time flows. This is called time dilation. And near the event horizon, it becomes extreme. To an outside observer, your time nearly stops. But for you, everything feels normal. Your heart beats, your thoughts flow. You cross the event horizon without even realizing it. The most terrifying part. Let that sink in. The moment you pass the point of no return, you don't feel anything. No pain, no warning, no sign that you are already lost. And that might be the most terrifying part of all, because by the time you realize it, it's already too late. And what happens next is even worse, because crossing the event horizon is only the beginning. The real horror
starts after. Your body, your atoms, even the structure of matter itself is about to be stretched beyond anything you can imagine. A process so extreme that scientists had to give it a strange name, almost like a joke. But it's not a joke. It's real, and it has a name you'll never forget. Spaghettification. Spaghettification, when your body stops being human. You've crossed the event horizon. There's no going back. But strangely, you're still alive, still thinking, still aware, and for a brief moment, everything feels normal. But that feeling won't last, because something is changing, not around you, inside you. The first sign. At first, it's subtle, so subtle you might ignore it. A strange sensation in your body, like being gently pulled from two directions at once. Your feet feel heavier. Your head feels lighter. You try to move your arms. They respond, but something feels off, like your body is no longer perfectly connected. Not broken.
Not yet. Just uneven. Gravity is no longer uniform. On Earth, gravity pulls everything equally. Your head and your feet experience almost the same force. That's why you don't notice it. But inside a black hole, gravity changes dramatically over very small distances. Just a few centimeters can mean a massive difference in force, and your body is caught in between. Your feet are closer to the center of the black hole, so they are pulled harder. Your head is slightly farther away, so it's pulled less. That difference is called a tidal force, and inside a black hole, it becomes overwhelming. The stretching begins. At first, it's just pressure. Then, it becomes tension. Your body starts to stretch. Not quickly, not violently, but steadily, relentlessly. Your spine elongates, your muscles strain, your internal organs begin to shift. You try to resist, but there's nothing to push against. No ground, no surface, only space and gravity. Your brain tries to understand. Your mind is still working, still trying to make sense of what's happening. But there is no reference for this.
No human experience, no instinct, because nothing on Earth prepares you for this. Pain signals begin to fire, but they're confused because this isn't injury in the normal sense, it's distortion. Your entire body is being rewritten. Why it's called spaghettification. Scientists needed a word to describe this process, and strangely, they chose something almost playful. Spaghettification, because that's exactly what happens. You are stretched, longer and thinner, until your body resembles a strand of spaghetti. It sounds absurd, almost like a joke, but it's one of the most extreme physical processes in the universe, and it's completely real. The force becomes extreme. As you fall deeper, the difference in gravity increases exponentially. Your feet are pulled far stronger than your head. Your body stretches faster now. Your bones begin to separate. Not break, separate. Because the force isn't hitting you all at once. It's pulling you apart, piece by piece, down to the atomic level. At some point, your body can no longer hold together. Not as a human, not even as tissue. You are no longer a person. You are matter, a stream of particles falling inward. Your molecules begin to separate. Atoms lose their bonds. Electrons are stripped away. What was once you is now just a line of energy being pulled toward the center. But here's the twist. This process depends on the size of the black hole. If the black hole is small, like one formed from a collapsed star, spaghettification happens almost instantly. You would be destroyed before even crossing the event horizon. But if the black hole is supermassive, like the one at the center of a galaxy, something unexpected happens. The tidal forces at the event horizon are much weaker. You could cross it without being torn apart immediately. You might survive for a little longer, minutes, maybe even hours, before the stretching begins. The illusion of survival. Imagine that, falling into a black hole and not dying right away. Still conscious, still aware, drifting deeper into something no human has ever experienced. But that survival is only temporary, because no matter how large the black hole is, the end is the same. The closer you get to the center, the stronger the forces become, until nothing can resist them. And yet, even after your body is completely destroyed, the story doesn't end, because what's waiting at the center
is something even more mysterious. A place where all the laws of physics break, where space and time stop behaving the way they should. A place so extreme that our equations simply stop working. Scientists call it the singularity. And what happens there might be the strangest part of all. The singularity, where reality breaks. Your body is gone. Not destroyed in an explosion, not erased in a flash, but stretched, pulled apart, until nothing remains but a thin stream of matter. And yet, you are still falling, deeper, closer to something we don't understand. The center that shouldn't exist. At the heart of every black hole, there is something that should not exist. A point with no size, no volume, and yet it contains the entire mass of a star, or even billions of stars. This is the singularity, and it breaks everything we know about physics. A point of infinite density. Let's try to understand it. Take something massive, like the sun. Now compress it, smaller and smaller, until it becomes a point. Not a sphere, not an object, a point. Zero size, but all the mass is still there. That means the density becomes infinite. Not extremely large, infinite. And that's where our understanding collapses. Because infinity is not something physics knows how to handle, where equations fail. Every law of physics we have, gravity, motion, energy, they all work beautifully. They can predict planets, stars, galaxies, even black holes, up to a point. But at the singularity, they stop working. The equations break, not slightly, completely. It's like trying to divide by zero. The answer doesn't exist, and that means something terrifying. We don't know what's happening there. Space and time collapse. Outside a black hole, space and time are separate things. Inside, they begin to merge, and at the singularity, they collapse entirely. Time no longer flows. Space no longer behaves like space. There is no direction, no forward, no back. Everything leads to the same point. The singularity is not just a place in space, it's a moment in time, a final destination that nothing can avoid. Is something even more mysterious. A place where all the laws of physics break, where space and time stop behaving the way they should. A place so extreme that our equations simply stop working. Scientists call it the singularity, and what happens there might be the strangest part of all. The singularity, where reality breaks. Your body is gone, not destroyed in an explosion, not erased in a flash, but stretched, pulled apart, until nothing remains but a thin stream of matter. And yet, you are still falling, deeper, closer to something we don't understand. The center that shouldn't exist. At the heart of every black hole, there is something that should not exist. A point with no size, no volume, and yet it contains the entire mass of a star, or even billions of stars. This is the singularity, and it breaks everything we know about physics. A point of infinite density. Let's try to understand it. Take something massive, like the sun. Now compress it, smaller and smaller, until it becomes a point. Bridges through space-time. But there's a problem. They would be incredibly unstable, collapse instantly, destroy anything that tries to pass through. So while the idea is fascinating, it remains purely theoretical. The edge of human knowledge. The singularity represents something deeper, not just a physical mystery, but a limit, a boundary of human understanding. We have built theories that explain the cosmos. We have mapped galaxies, measured time, even predicted black holes before we ever saw them. But here, at the center, we are blind. Why this matters? This isn't just about black holes, it's about the universe itself. Because if our laws of physics break here, what else are we missing? What other parts of reality are we misunderstanding? Black holes are not just objects, they are clues, hints that our current understanding is incomplete. But even this is not the most disturbing part, because there's a deeper mystery, one that challenges the very foundation of science, a rule so important that if it's wrong, everything we know could collapse. It's the idea that an information can never be destroyed, and yet black holes seem to do exactly that. So the question is, what happens to everything that falls inside? Is it truly gone? Or is the universe hiding something we haven't discovered yet? The information paradox, the universe's biggest mystery. You've crossed the event horizon. Your body has been stretched, torn apart, reduced to particles, and finally, you reach the singularity, a place where everything ends. Or at least, that's what it looks like. Because in physics, there is a rule so fundamental that if it breaks, everything else might break with it. The rule that can't be broken. Information can never be destroyed. This isn't just a theory, it's a foundation. Every particle, every atom, every interaction contains information. The structure of your body, the pattern of your brain, every memory you've ever had, all of it is encoded in the arrangement of matter and energy. And according to the laws of physics, that information must always exist. It can change form, it can be scrambled, but it can never be lost. Black holes break this rule. But black holes don't seem to follow this rule. When something falls in, it disappears. Not just hidden, gone. No signal escapes, no trace returns. From the outside, it's as if the information never existed at all. And that creates a paradox.
Because if information is destroyed, then physics, as we know it, is incomplete. Why this is a big deal? This might sound abstract, but it's not. If information can be destroyed, then the universe becomes unpredictable. You could take the exact same starting conditions and get completely different outcomes. Cause and effect would break. Reality itself would stop being reliable. And that's why this problem matters. Because black holes are forcing us to ask, are the laws of physics actually correct? Stephen Hawking's shocking discovery. In the 1970s, a physicist named Stephen Hawking made a discovery that changed everything. He showed that black holes are not completely black. They emit radiation, very slowly, very faintly, but over time, they lose mass, they shrink, and eventually, they disappear. This process is now known as Hawking radiation. Black holes can die. This idea was shocking because it means black holes are not eternal. Given enough time, they evaporate. A small black hole might disappear quickly, but a supermassive one could take longer than the current age of the universe, trillions upon trillions of years. But eventually, they are gone. So where does the information go? And here's the problem. If a black hole disappears, what happens to everything that fell into it? All the matter, all the energy, all the information. Does it vanish? If yes, then physics is broken. If no, then where is it? The problem with Hawking radiation. Hawking radiation looks random, completely random, like static noise. It doesn't seem to contain any information. No pattern, no structure, nothing that could reconstruct what fell in. So if black holes evaporate and only random radiation comes out, then the information appears to be lost forever. The paradox defined. This is the black hole information paradox. Two ideas that both seem true, but cannot both be correct. 1. Information can never be destroyed. 2. Black holes destroy information. They can't both be right, and yet we have evidence for both. Possible solutions. Scientists have proposed many ideas, none of them fully proven, but all of them fascinating. Theory 1. Information is stored on the surface. Some physicists believe that information is not lost inside the black hole. Instead, it is encoded on the event horizon, like a hologram. Every particle that falls in leaves a trace on the surface, a 2D imprint of a 3D reality.
Bridges through space-time. But there's a problem. They would be incredibly unstable, collapse instantly, destroy anything that tries to pass through. So while the idea is fascinating, it remains purely theoretical. The edge of human knowledge. The singularity represents something deeper, not just a physical mystery, but a limit, a boundary of human understanding. We have built theories that explain the cosmos. We have mapped galaxies, measured time, even predicted black holes before we ever saw them. But here, at the center, we are blind. Why this matters? This isn't just about black holes, it's about the universe itself. Because if our laws of physics break here, what else are we missing? What other parts of reality are we misunderstanding? Black holes are not just objects, they are clues, hints that our current understanding is incomplete. But even this is not the most disturbing part, because there's a deeper mystery, one that challenges the very foundation of science, a rule so important that if it's wrong, everything we know could collapse.
It's the idea that an information can never be destroyed. And yet, black holes seem to do exactly that. So the question is, what happens to everything that falls inside? Is it truly gone?
The universe speeds up. As you fall deeper, time outside the black hole speeds up, faster and faster. Millions of years passing in seconds. Stars forming, exploding, galaxies colliding. You might witness the future of the universe before you reach the center. Light behaves strangely. Light around you bends, wraps, distorts. You might see the entire universe compressed into a glowing ring around you, a warped image of reality, beautiful but deeply unnatural.
Or nothing at all. Or maybe you see nothing because light cannot reach your eyes anymore. No signal, no image, just darkness. Absolute darkness. Reality becomes uncertain. At this point, concepts like space and time lose meaning. You are no longer experiencing reality the way humans understand it. You are inside something that rewrites the rules. Black holes are questions. Black holes are not just objects, they are questions. Questions about space, about time, about reality itself. They challenge everything we believe.
The limit of human knowledge. We have built incredible theories. We have explored the universe, sent machines beyond our solar system, captured images of black holes. And yet, at their center, we are still lost. A quiet warning. Black holes remind us of something important, that the universe is not fully understood, that there are limits to what we know, and maybe limits to what we can know. Somewhere out there, in the silent darkness of space, millions of black holes are waiting, invisible, unstoppable, and maybe holding answers to questions we haven't even asked yet. Or maybe they are something else entirely. A reminder that there are places in this universe we were never meant to understand.